7:02. The Naked Scientist.
Right, it's 22 minutes to 3 o'clock. Yes, indeed, it's time for us to connect with Dr. Chris Smith, the Naked Scientist, for your science-related questions. Hello, Chris.
Hi, Ezra, how are you?
I'm so good. I'm sitting in front of the Wanderers Oval. I'm not sure if you're a cricket fan. I've never been to a cricket match in my life, but I've been to Wanderers, this particular precinct, before for other non-cricket related events. And I just realized, oh my goodness, I've never been to a cricket match. And how long would it take for me to ever get to a cricket match, considering the lockdowns and a pandemic?
Have you learned all the rules?
I used to watch it many years ago. In my teens, it was a sport I used to love. So I need to brush up, but yeah.
Oh, you're back from the wilderness then.
Yes, you could say that. You could say that. Ready to brush up, though. But it's lovely being here, being able to look out at this vista, an empty stadium. What a reminder of this moment that we're living through.
Yeah, I'm looking forward to even the most mundane and trivial things are becoming exceptionally valuable, aren't they? And in the post-lockdown era, as one person said to me the other day, they ordered something via online delivery just so they could see another human. And it was like, just for that fleeting moment of signing on the dotted line to get a delivery, it was like a human, another person. I interacted with another human for the first time in days. It's the small things. It's the small things that appeal. But no, it will. It's a giant red reset button for everybody, this, isn't it? And it's going to make us reevaluate and really, I think, get back to what we appreciate about life, I think. Certainly it is. It's making me think again.
Yeah, absolutely. Well, I've got two questions of my own, but I'm going to put them on the back burner because our lines are already blazing. Chris, let's go to Joey, who's calling us from Sandton. Hi, Joey.
Hello, how are you?
Very good. Welcome.
Thank you very much. Chris?
Hi, Joey.
Hi. You know, when we speak about a car, for instance, say car is efficient, we mean like the fuel that it takes, how much of that it uses, and how much of that is waste.
Mm.
Can we mention that, about the human body? Can we say, for instance, the food that we take, of the stuff that is wasted or discarded as waste?
Yeah, we can do that. People are doing that. And we know the calculations for a human. Now, it will probably shock people to realise that your car is only about 30% efficient. In other words, only about a third of the energy in the petrol or diesel you put into the tank actually turns into useful work on the part of the car. The vast majority is wasted as heat. And this is just an intrinsic constraint of the way that the process that we use to extract energy out of our fuel to make our cars go along actually works. And it's the same with the electricity coming from the power station. Not more than 50% of that actually has turned into useful power in your home. More than half of the energy that got converted in the first place to make the electricity just went up a chimney or a cooling tower somewhere. And the human body, not much better. Our muscles actually are only about 25-30% efficient. So in other words, when we burn an energy molecule in our body, whether that's, we tend to talk about it as a chemical called ATP, which is adenosine triphosphate. That's our energy molecules that we can liberate energy from by rearranging chemical bonds. Only about 30% of the energy when you do that reaction turns into useful mechanical energy in your muscles. The rest is turned into heat. And that's why when you go for a run, you get hot and you sweat. And if you're cold, you shiver. And when you're cold and shivering, what your body is doing is it's activating both sets of muscles on both sides of a joint at the same time, because then the muscles work against each other, and that's why you shake, because one muscle pulls a bit, and it pulls a bit harder than the other one, which makes the other one work a bit harder, so it pulls back, and you have a tug of war between the two muscles. In the process, they're burning off enormous amounts of energy, producing a lot of heat, which is going into the blood through the muscle, back into the centre of your body and warming you up. So yes, we can make the same calculations. We're roughly equally inefficient with a car. About 30% of the energy that we eat actually turns into useful things going on in our muscles. The rest gets turned into wasted heat, unless you're looking at a politician, in which case most of what comes out of their mouth is hot air anyway.
Thank you.
Joey, what a brilliant question. But I guess, Chris, every system has waste, doesn't it?
Yeah, and in my experience, many parliamentary systems have more than their fair share. But there we go. So do some radio broadcasters, to be fair, to our profession as well.
Yeah, exactly. But there's also losses in the system.
Yeah. That's
in
right, and that's
any
the heat.
system.
We throw away that heat because we sweat to lose the heat. We also go to the loo and chuck away heat in urine. We also do a number 2, that's hot. So all these routes out of the body are the energy, the heat that we're making in burning off energy from food is turned into heat, which then leaves the body one way or another.
Amazing. Amazing. Great. So thank you for that question, Joey. And then we also have, is it Kolisani joining us from Pretoria? Hi, Kolisani.
Hi, Azani. How are you?
I'm good. How are you?
I'm very well, thank you. I've got a question. There is currently a weakening of the magnetic field, of the Earth's magnetic field between South America and Africa. And apparently, this might cause a shift of the North Pole and a swap, in fact, a switch between the North Pole and the South Pole. But then this apparently happens every 728,000 years or something like that. Now, my question is, when that switch happens, I would assume it doesn't happen overnight. It's a slow process. And as it happens, I would assume for some time, the Earth will slowly shift, and then we'll have the North Pole on the west, rather, before it finally switches to the south. And we'll have the South Pole on the east, if that's an anti-clockwise switch, assuming. Now, my question is, wouldn't it that then cause the Earth to drift towards the sun as opposed to orbiting around it? And, of course, cause the cosmological imbalance with its moon.
Yeah.
And what's your take on that?
Okay, very lovely
Wow.
question. Thank you for that.
Thank you for
And
listening.
the answer to this is that, first of all, the Earth's magnetic field has been flipping around every between 100,000 years and 1,000,000 years for the entire history of the Earth. Now, you might say, how do I know that? Who was here to know that? And the answer is, craftily, you can look in rock specimens and you can find a pattern of the Earth's magnetic field written into them. And so if you date the rock, you can date the magnetic field written into the rock, and that tells you that at certain points in Earth's history, the Earth's magnetic field pointed in that direction, and later on it pointed in this direction. And this is how we know that the poles have done this so-called flip, where the Earth's magnetic north becomes south and south becomes north. Now, we don't know exactly how the Earth's magnetic field works, but we know it's got something to do with the fact that inside the Earth, deep within the Earth, about 6,000 kilometres in, is the core, and the centre of the Earth, the very core, is solid, but around that solid iron core is a liquid iron molten core, which is in motion, and as it's orbiting around its central core, it is creating these currents. It's a so-called geodynamo, which gives rise to the magnetic field. Now, that field at the moment is very important because it comes out of the North Pole, goes around in field lines that then go into the South Pole, and it protects us from incoming radiation, charged particles, the cosmic wind, the solar wind that's coming past the planet at 1,000,000 miles an hour and would otherwise desiccate our planet, and we'd end up looking like Mars. Very important to us, but we do know it has changed in the past many, many times from these rock specimens. It's also been wandering a bit, and there is, as was alluded to in the question, a pulse of activity from South America towards the beginning of the year, and this has caused it to shift a bit more. So it is wandering across the Earth's surface. And also we've got old ships' logbooks. If you look at Captain James Cook, when he was exploring the southern hemisphere and out towards the Australia's, New Zealand, the Antipodes, you can see that what he was recording as magnetic north is not what we would call magnetic north today. So it's wandering around. So we've got the historical record and we've got the geological record for this. But the evidence is that when this does collapse, this field, it then fairly promptly reestablishes. It can't be down for very long because the planet would be damaged. And so we think that the field probably takes a while to diminish, and then it reestablishes in a new direction. But in geological terms, it's happening very, very quickly. This will not have any effect on the trajectory of the planet round the sun, because the thing that is the dominant force keeping our planet tethered to the sun is gravity, And although the magnetic field may change a bit, this is not going to affect the gravitational attraction between the Earth and the Sun in any demonstrable way. Therefore, the Earth will still continue on its present orbital trajectory. It would just have compasses a little bit confused in your car, and possibly your some satellites would succumb to some damage because they rely on the Earth's magnetic field to defend them from radiation from space. So some communications might not work so well for a while, but on the whole, nothing else is going to change.
Wow, so much going on that we just simply don't see carrying on and with our lives. Meanwhile, there are planetary forces at play. But I quickly want to squeeze in my question after what Kholisani has asked about what the reports we saw last week as well about the sun, that the sun is experiencing a less active phase. That's called a solar minimum.
Yep.
Now, scientists are saying, well, it won't cause an ice age. And some are saying it could be due to climate change, because previously it did cause an ice age in the northern hemisphere. What is a solar minimum? What's happening with the sun?
Well, the sun goes through an 11-year cycle, and so it has maximum activity and minimum activity, and this follows this 11-year cyclical behaviour. And we know this has been going on for a really long time as well, because we can go back in the history books and we can look at people's documentation of various markers of what weather was doing, what the climate was doing. And this is both historical records, but also you can look at trees and things, because trees have obviously lived for hundreds of years, and you can look at the growth rings in trees, which tells you a lot about the climate. And trees grow more when the weather's good, they grow less when the weather's bad. And you can then marry that up to other records, for instance, chemical records of what the rain was doing and what the temperature was doing at the same time. And we can see this pattern written into all those independent records, that there are boom and bust, which is almost certainly tethered to what the sun is doing. You've got to also add other factors into it, but you can see this 11-year cycle. Some of the water levels change in some of Africa's Great Lakes with a similar cycle. And you can see that in how the water levels are recorded geologically in those lakes. And so we know this has been going on for a long time. We don't understand exactly why the sun has the cycle that it does, but it has this cycle. And when it's at a minimum, what's happening is that the sun has low sunspot activity. It has low magnetic flux activity, so it's less likely to fling off chunks of charged material into space. And therefore the amount of energy hitting the Earth is a bit lower at those times. And when the sun's in a maximum, it's flinging out far more radiation and far more charged material and having more so-called coronal mass ejections and sunspots. And that is associated with knock-on effects on Earth's climate for various reasons. And when we have these minima, that's what it coincides with cooler periods of Earth, and maxima, you have hotter periods on Earth, and changes in rainfall and so on.
Right. Okay. Let's go next to Palisa calling us from Bramley with a question. Hi, Palisa.
Hi, Azania. Hi, Chris.
Hi, Melissa.
I just wanted to find out what causes dwarfism. What makes other people born small, little people? I think from what I see, I don't think there's a disease, because there's nothing wrong with them. It's just that they're small people. We have one guy from where I come from who's small. He's like late in his 60s. There's really nothing wrong with him. It's just that he's small. And why is it such a very small population of dwarfs worldwide?
Okay.
Yeah, okay. Well, there are two things to consider here. Some people have small stature relative to everybody else, as in they just didn't grow very tall, but they're otherwise normally proportioned. They just haven't grown very big. And that can happen because an individual has a poor diet or a poor upbringing. And a good example of this, my best friend at university, medical school, his parents are from Bangladesh. He was my best man at my wedding. And so we went down to see his parents after we got married. And we went to their house where they lived. And he said, look at this is quite funny, because he's the same height as me, my best man. And I'm not very small. I'm not huge, but I'm not very small. And we went into his parents' house, and he said, "Look at this; it's quite funny." And they had their mirror, so they could stand and get dressed and ready. And when we looked in the mirror, I could only see my chest downwards because the mirror was so low on the wall. And the point that we were making, and the point where this story is going, is that genetically, my best friend, my best man, is made from the genes in his parents. They grew up in a poor place in Bangladesh. They didn't have enough food and didn't have a completely, life free of infection when they were small. So their body was facing many more challenges as they were growing up. So they didn't reach their full genetic potential. Whereas my friend who grew up in the UK was well nourished, looking at the size of his gut these days, even better nourished. And so he did reach his true genetic potential. So even though he's very close to, he's 100% genetically from his parents, he's grown much taller than they did. And that is because of better living conditions. So that's part of the equation. But then there's an exception, a different thing, which is there is a condition called dwarfism. It's actually achondroplasia, and this is an inherited condition. If you have the gene for this, then it affects the way in which the long bones in the body grow and develop, and as a result, they tend to be shorter than they should be. And if you've got a parent who's got this, there's a 50% chance that they'll have a child who has this. If you've got two parents with it, obviously it depends on what the genetics are, but there'll be a much higher prospect of that happening. And the individuals just don't develop long bones like thigh bones and arm bones, which are as long as their non-affected adult counterparts. So you end up with a person who anatomically looks normal but is small, and that's called achondroplasia.
There we go. Palisa, thank you so much for the question. That's Palisa calling from Bramley there. And then we go off to Andrew in Hammanskraal. Hi, Andrew.
Hello, Azania. Dr. Chris, hi.
Hi, Andrew.
I've noticed in the past 3-4 months or so, at new moon, there's a star. It's quite bright, and it comes out earlier than the other stars. But with the naked eye, I can tell that it's not up there with other stars. It's actually between the moon and the stars. So I think it is a planet. Am I right?
Yeah, hi Andrew. The fact that it's appearing in a different place in the sky at different times of the year, and you're noticing at this time of the year, the reason that we call planets planets, it comes from the Greek word planetes, and that means wanderers, because the ancient Greeks, when they looked heavenward, they realised that there are two types of stars, what we're calling stars. There are stars that tend to stay in the same place relative to each other all the time, and then these other stars that wandered all over the sky at different times of the year and relative to each other. And so they called these special group of stars the planetes for wanderers. They didn't realise that the stars that didn't move around were distant stars like our sun, but the planetes, the wanderers, are planets. And the bright star you're seeing quite close to the moon is probably Venus. Because it's close to us, it's our near planetary neighbour, and it's very bright. It tends to come up early and be very bright and shiny, and you'll see it quite close to the moon at the moment. So you're probably seeing Venus, and it is indeed a planet.
Right. I remember in school we had to learn that line that tells you the order of the planets.
Go on then. I challenge you. Go on then.
Jumped.
Go on.
I couldn't finish it, Chris. Why did you do that? I was well on my way.
Oh, sorry. There's a bit of a delay on the line, and I didn't realise you got started. I was hoping to get in there. So go on then. From the centre. Yeah, well, the first one closest to the sun is Mercury.
Mercury is
then
then
Venus,
like
then
said now, then
Earth, then
Mars.
Very
After
good.
that, my very earthly mother.
And then we got the asteroid belt, and then the big one with a J, Jupiter.
Oh, Jupiter.
Yeah, and then after Jupiter
so
is
Neptune.
there's people shouting at the radio all over Johannesburg now.
Get it. I'll have to go back to my high school books. My goodness. But yeah, we had to learn that line to help us remember.
It obviously worked then.
Ace it in the exam. Well, half worked. Look at me now. Useless as it gets. Just halfway. Can't get half a mark.
Well, that's okay. As long as you're becoming a space scientist who's only sending a probe as far as Jupiter or Saturn, you're going to be fine.
Then I'll be fine, absolutely. As long as you're getting past Mars. Thank you so much,
All right.
Chris.
You take care. Have a good one. Bye, everybody.